This is an overview of big data, Hadoop, and Hadoop's ecosystem. Many topics are discussed in this document, so feel free to visit the websites on selected pages of this document. This document will cover Pig, HDFS, Scoop, Hive, Mahoot, MapReduce, Hue, hbase, Flume, Java, oozie, and Impala. Big data can handle large volumes of data, so it's great when trying to understand social media information, data being streamed, and data gathered from sensors. Big data is good at handling velocity of data, dealing with near real-time information such as RFID tags, sensors, smart meters, geolocations, imagery, and audio. Big data is also good at handling information from varied systems such as traditional RDBMS, audio, emails, and video. Hadoop analysis allows users to perform the following: text mining, collaborative filtering, prediction models, sentiment analysis, risk analysis, index building, graph creation and analysis, and pattern recognition. With traditional RDBMS systems, data is stored centrally. It is then copied to the processors at runtime, which is good for limited amounts of data. With distributed systems, data is distributed when stored. The data is then processed by the node which the data is stored on. On a node, from the bottom up, you have the disk storage, the native OS file system, followed by HDFS, which will sit on top. Hadoop has many nodes. You have the slave node, also known as the worker node. The slave node has low-cost hardware and cheap storage. There could be many slave nodes, and is used to store HDFS data. You have the name node. The name node has more expensive hardware than the slave node. It's a master node. It manages HDFS and stores locations of files on HDFS. You have the job node. The job node uses more expensive hardware than the slave node. It's a master node and manages MapReduce jobs. HDFS supports fault tolerance. Files loaded onto HDFS are split into different blocks. These blocks are then replicated on different nodes. The name node keeps track of what blocks are on which nodes. When the files loaded into HDFS is split into different blocks. Records from these blocks are then run in different mappers, which are assigned to different partitioners, shuffled and sorted. The reducer jobs then run, output in the desired format and into a file. MapReduce is a method for distributing tasks across multiple nodes. Each node processes data stored on that node. MapReduce consists of two phases, map and reduce. MapReduce uses fault tolerance. MapReduce abstracts all housekeeping from programmers. Here are the components of Hadoop. You can see that in the ecosystem you've got Scoop, Flume, Hive, Pig, Mahoot, hbase, oozie, and there are many other tools which can also be used. In Hadoop core components you have Hadoop MapReduce and Hadoop HDFS. HDFS is a file system written in Java. It sits on top of the existing file system and provides redundant storage for massive amounts of data. MapReduce is a method for distributing tasks across multiple nodes. It consists of two phases, map and reduce. Each node processes data that's stored on that node. Scoop transfers data between RDBMS and HDFS. Scoop transfers data efficiently using map-only MapReduce jobs. Scoop supports ODBC and JDBC. Scoop also uses connectors to efficiently transfer data. Scoop supports command line interface. Supports incremental loads of a table to Scoop. Saved jobs can be run multiple times to import updates made to the database since the last import. Kerbos security integration is also supported by Scoop. For more information on Scoop, visit www.scoop.apache.org. Flume is a reliable service for collecting, aggregating and moving large amounts of streaming data into Hadoop. Flume allows users to stream data from multiple sources, collect high volume of data such as weblogs, and guarantee delivery. Flume has many different types of components. You've got the agent. The agent runs Flume in a Java virtual machine, also known as JVM. Uses a collection of sources, channels and sinks. Source. The source listens out for events. Flume agents may have multiple sources. Requires a name and type of source. On consuming an event, Flume sources write the event to a channel as transactions. Channel. The channels used by Flume agents to transfer events from their sources to sinks. Events are written to the channel by a source and are not removed. Sink. The sink takes transactions from the channel and writes it to the output. Transactions are closed when successfully written to the output. Here's an example of Flume on a host machine. Here you can see the source, channel and sink run within a JVM. For more information on Flume, go to www.hortonworks.com/Hadoop/Flume. Hive was developed by Facebook for summarization, querying and analysis. Hive supports large datasets stored in HDFS. Hive uses SQL-like language called HiveQL. HiveQL queries are converted into mapreduce when executed. Hive supports built-in and custom user-defined functions, also known as UDF. We'll now talk about Hive's performance from fastest to slowest. The fastest query that will run will be a describes query, which uses the metadata. Next on the list will be a select all from, which uses data read from HDFS. Then a select all from using a where statement, which uses a map only mapreduce job. We have a select count from using a where statement, which uses a mapreduce job. Finally, our slowest is a select from using a count, grouping and order by, which uses multiple mapreduce jobs. Here you can do the comparisons between the RDBMS and Hive. For more information on Hive, visit www.hive.apache.org. Pig is a high-level language used to analyze large datasets. Pig can be run from the command line or interactively using the grunt shell. Pig can be run locally or on HDFS. Pig queries are converted and run as mapreduce when required. Pig expects loaded files to be in a tab delimited format as default. Pig only executes queries when a store or dump command is issued. Here we'll go through some pig terminology. The pig dump command will dump pig queries onto the user screen. The pig store command would store pig queries in HDFS. Here we have further pig terminology. We have a field, a tuple and a bag. Here I've used Excel to demonstrate what a field, tuple and bag looks like. Here you can see that a field looks just like a cell on Excel, whereas a tuple can be a row or part of a row. Here you can see a pig bag consists of rows and records. For more information about pig, visit www.pig.apache.org. Mahoot is an intelligent software which learns from user data input. Mahoot uses machine learning to improve output based on previous experiences. Mahoot focuses on machine learning tasks such as collaborative filtering, clustering, and categorization. For more information on Mahoot, visit mahoot.apache.org. Oozie is a Java web application used to schedule Hadoop jobs. Oozie combines multiple jobs sequentially into one logical unit of work. Oozie is integrated with Hadoop's ecosystem and supports Hadoop jobs for mapreduce, pig, hive, and scoop. Oozie can be used to schedule jobs specific to a system like Java programs or shell scripts. Oozie triggers workflow actions, but Hadoop MapReduce executes them. Oozie leverages other capabilities within a Hadoop stack to balance load and handle failures. When Oozie starts a task, it provides a unique callback HTTP URL to the task, notifying that URL when it's complete. Oozie can also manage multiple workflows that are dependent on the outcome of subsequent workflows. For more information on Oozie, visit www.oozie.apache.org. hbase provides random real-time access to your big data. hbase was created for hosting very large tables with billions of rows and millions of columns. The pros of hbase are that it has real-time random big data access, high scalability, high reliability, auto failover, and a simple client interface. The cons of using hbase are you can't perform any joins. Instead, you would have to use mapreduce. You can only use an index on a key, and currently there are a few security problems. However, there is an alternative to hbase called accumulo. For more information, visit www.hbase.apache.org. Impala is a query engine that's used on Hadoop. Impala has daemons that run on all nodes, which caches data from HDFS. Impala daemons can return data a lot quicker because no MapReduce jobs are required. Impala has no fault tolerance. Impala is great for ad hoc queries. Impala uses a SQL-like language similar to Hive. Impala can run up to 65 times faster than Hive. Impala is compatible with existing Hadoop applications. Impala can access Hive-specific tables as they share the same metastore. For more information on Impala, visit www.impala.io. Hue is an open source web interface which allows users to interact with Hadoop's components. Below are a few examples of what can be done on Hue with a few clicks. For example, upload and browse data, run pig, hive, and Impala queries, schedule queries, load data into HDFS using Scoop. For more information on Hue, go to www.gethue.com. With everybody talking about big data, people are starting to ask the question, what will happen to some of the products such as SAS, SQL Server, MySQL, and Oracle? Big data works on massive amounts of data and doesn't provide some of the functionality that products such as SAS, SQL Server, MySQL, and Oracle can offer. Therefore, developers and analysts will still be required to use these tools. Analysts and developers using big data technologies will have to be upskilled so they have an understanding of Java and other languages such as Python. They'll also have to have a knowledge of the server so they can understand how many slots are available when running jobs such as MapReduce. If you have any questions, please contact me on jmensa60@gmail.com.